a very brief introduction here to the next set of videos. I'm going to start talking about contingency tables. And so our interest really is derivative of this from Cook and Campbell we've seen already. I keep saying if I say it over and over and over again, it must be important. Sort of rules for causal. For causal inference, rule number one is that you need to show or believe that your two variables, an independent variable and a dependent variable, are not independent. If they're independent of each other, then that's the end of the line. And so we can begin then trying to get an understanding of how we examine whether or not two variables are independent of each other using contingency tables and measures at either the nominal level or the ordinal level, or nominal and ordinal together, starting very basically with a 2x2 table. Sometimes contingency tables are called crosstabs. We're going to see and then drill on several examples. And we're going to learn to test for departures from statistical independence. Need you to recall the definition of that. This is in terms of the probability of events. You've seen this as the PPA given B. Probability that A is equal to 1 given B equals the probability that A, here Y, and X is substituted. So we're going to start with two binary variables and learn about a statistic called chi-square that helps us gain leverage on inferring whether from a sample to a population we have a real result of statistical dependence as an alternative. So the probability that Y equals 1 given X, if that equals simply the probability that Y equals 1, it means X has no influence. That X and Y are independent. And we're going to examine chi-square, a very, very powerful family of distributions that are of fundamental importance in statistical inference as a mechanism for determining empirically whether it's fair or not to say that two variables are related and that therefore they jump through the first hoop of the rules that we lay out for causal inference. Several more videos to follow in this sequence.